An AI agent just used Vim. Not by reading a file. Not by calling an API. It opened Vim, navigated to a line, made an edit, and saved. Like a human would. That is what tui-use makes possible, and it changes what we thought AI agents could actually do in a terminal. Most AI coding tools today operate on files. They read them, write them, maybe run a shell command and capture the output. Clean, stateless, predictable. But a huge chunk of real DevOps work does not happen in files. It happens in interactive programs. Programs that expect a human on the other end, pressing keys, reading output, reacting. Programs like Vim, htop, tmux, psql, or the MySQL shell. Until now, AI agents hit a wall there. tui-use tears down that wall. Here is what it actually does. tui-use is a Python library that wraps interactive terminal programs, specifically TUI apps, which stands for Text User Interface, and exposes them as something an AI agent can drive. It uses a pseudo-terminal under the hood, meaning it creates a fake terminal that the TUI app thinks is a real human terminal. The agent sends keystrokes programmatically. It reads back the screen contents as structured text. The app has no idea it is talking to a machine. In practice, this means you can write an agent loop where the AI decides to check system load, spawns top, reads the current CPU and memory state, then exits cleanly. Or it connects to a PostgreSQL database through psql, runs a query, reads the result table from the screen buffer, and makes a decision based on that data. Or it opens Vim, jumps to a specific line using Vim's own navigation, edits it, and writes the file. All of this through the normal keyboard interface that humans use. No special API. No plugin. Just keystrokes and screen reads. The API is remarkably simple. You give it the command to launch, you send keys with a send method, you get the screen back with a read method. There is a wait mechanism so the agent can pause until the screen stops changing, which is how you know a command has finished. That detail matters a lot in practice. But here is the thing, and this is where the honest part comes in: tui-use is not magic, and it has real edges. The screen reading is text-based. It captures what is visible on screen right now. It does not give you structured data, parsed tables, or semantic understanding of what is displayed. The AI has to look at raw terminal output, which can include ANSI escape codes, box drawing characters, partial renders, and make sense of it. If you are sending this into a language model, the model needs to be reasonably good at interpreting terminal output as plain text. Some models handle this better than others. Timing is fragile. TUI apps do not signal completion the way an API does. You are essentially watching the screen and guessing when the app is done reacting. The built-in wait mechanism helps, but complex apps with async rendering can still fool it. If your agent acts too fast, it might read a screen that is still mid-render. And right now, tui-use is a library, not a system. There is no built-in agent loop, no memory, no error recovery. If Vim enters an unexpected mode because the AI sent a wrong key sequence, the agent needs to detect that and correct it. That recovery logic is on you to build. What surprised me was how close this already is to being genuinely useful for a narrow set of tasks. Specifically, tasks where the interactive program is the only interface available: legacy database CLIs, embedded system consoles, network equipment shells. These are real environments where you cannot just swap an REST API. So what could this realistically become? The most plausible near-term use is pairing tui-use with a small agent framework, something like a LangChain tool or a Claude tool-use call, to give an AI assistant the ability to handle terminal sessions that require real interaction. Think of a DevOps copilot that can actually SSH into a box, check process status in top, query a database, and report back. Not by parsing log files after the fact, but by doing what a human junior engineer would do: live in the terminal. There is also an interesting testing angle. TUI apps are notoriously hard to test in an automated way. tui-use could become the foundation for a test harness that drives TUI programs the way Selenium drives browsers: send inputs, assert on-screen state, catch regressions. That would be genuinely valuable for open-source terminal tool maintainers. Deployment on a cloud VM also opens up possibilities: an agent that monitors its own infrastructure by literally watching the tools a sysadmin would watch. DigitalOcean droplets running headless agents with tui-use access to system monitoring tools is not far-fetched at all. So why does this exist? The problem it solves is deceptively simple but important: the gap between what AI agents can call and what humans actually operate. APIs are the clean path. But the world is full of software that was never designed to have an API. Decades of tooling built for humans sitting at keyboards. Tui-use is an argument that agents do not need to wait for those tools to modernize. They can meet them where they are. The author, OneSuper on GitHub, is essentially building a keyboard and eyes interface for AI, the same primitive that screen readers and accessibility tools use to bridge humans with software, now repurposed to bridge AI with software. Is tui-use production ready? No. Is it a research prototype with a clear real-world purpose? Absolutely. For teams dealing with legacy CLIs, interactive database shells, or any TUI-only tool, this is worth watching closely. Next episode, we are looking at an AI tool that does something similar but on the web side, controlling browser interfaces that were never designed for automation. If that sounds familiar, the differences are more interesting than you think. Subscribe so you catch it.